missing today too. So.
Yeah, that's true. Okay, so this is part 2. Everyone got your notes out in front of you there? Right, you should have some blanks to fill in. So we are talking about waste disposal. We just got finished talking about thermal treatment. Watched some videos there. Talked a little bit about burning, pyrolysis, gasification of garbage waste. Another method of waste disposal is exportation. So that is exporting or taking garbage away, far away from where it exists. Large cities such as New York transport their garbage off-site. So think about a large city that is very, very dense, very closely populated. There's a lot of garbage in virtually no space to put it. Any of you ever been to New York City?
Yes.
Yes? Okay. If you've been to New York City, you would know that every square foot of that city is packed full of big buildings, and it's amazingly dense. And there's a lot of people that walk through there. There's no place to put garbage. It's very, very, it's all that area is taken up with buildings and roads and subways and even underground subways, and it's amazing. So one of the obvious solutions is exportation for garbage for New York, let's say. So New York plans to float increasing amounts of garbage on garbage barges to North Carolina over 700 miles away. Cities that wish to transport excess garbage in this way must pay millions of dollars per year to other states and provinces to take their garbage. And you could probably understand if like where we are, we're in Saskatchewan, and it's fairly sparsely populated. We don't have a high population compared to like a large city like New York. Now, if New York could get their garbage out into the country somewhere, that would be ideal for them, but it wouldn't be the best for maybe the people that enjoy their open space and have agriculture and things like that. So it would cost some money. It would cost some money for these places, the regions, to deal with the garbage. So this does happen, but it does cost money. All right, in your textbook, find in your textbook. I think it says in your textbook. So look this up. Take a moment, look this up right now. Research how much New York paid for their garbage exportation in 2011. Now, this is a picture. I can't quite tell if that's New York or not. I don't think that's New York. That looks more like Chicago. This picture I got off the internet, but this is that's a picture of a garbage barge. And a barge is just a big, large, floating platform. A big barge. It's not like a boat shape, or anything. It's just a big, floating platform. And so that's an example of a garbage barge. Garbage being taken away from a city in the background. Okay, did you find a number?
Yeah.
Frozen.
What?
I am frozen still.
$300
Frozen.
billion.
300 million? Congratulations, Noah. Good job.
Thank you. Thank you. Bonus marks?
Bonus marks? No. Research in your textbook or online. 300 million. Yeah. Can you believe that? I can hardly believe that. That's like astronomical. 300 million. Actually, what's interesting about this, that's the same number as meters per second for 300. That's the same number as the meters per second that the speed of light goes.
No.
3 times 10 to the 8.
That was 2.99 to the 10 to the 8.
No, it's 3. No. Your speed of light's slower than mine. Yeah, in most calculations in high school, you use 3 times 10 to the 8. There would be exact number, I'm sure, that no one actually knows, but it would be close. So 300 million, that's a lot of money. A lot of money. A main way of reducing waste is by diverting waste from the waste stream, of course, by recycling and composting. We've talked about this several times in this course already. So reduce, reuse, recycle, still 3 very important words that helps us to manage waste. Reducing and reusing material that we use also is another method of source reduction. Okay, source reduction, reducing the source of garbage, let's say. Source reduction reduces waste or its ability to cause harm through design, manufacture, purchase, use, and reuse of a product. So source reduction is basically, starting off with less things that are going to contribute to the waste. So is the design of a project such that there's not a lot of waste materials being used? In the manufacturing process, how much extra material is sort of shoveled into the garbage, you know, on the floor of the manufacturing plant? You know, how much little excess things do you cut off that you don't need, that you garbage, right? Purchasing, are we choosing to purchase things that are created responsibly? And do we use and reuse a product? There's lots of things that you can reuse around home. What are some things that you guys reuse around home? Let's just talk about this for a second, because I'm sure some of you guys have a really good idea. Okay, plastic bags. There's not a lot of plastic bags being sold or given away at stores anymore, but if you have plastic bags that you use for certain things, certainly you can reuse plastic bags. Yeah?
Tea towels, like after I wash, obviously.
Okay, so towels to dry your dishes and stuff like that? Yeah. Yeah, so you don't buy a tea towel and then use it once and throw it away?
No.
Good for you. That's really good. Okay, good job. Even, I would dare even say, one way you can also help the environment is to maybe reuse your tea towels a little bit more. And use them once and you wash them. Well, you're using heat and energy and all that sort of stuff and water to wash your tea towels. If your dishes are really clean and they're just wet, you could probably reuse your tea towel a few times before you.
That's what we do when we
Yeah,
dry them.
yeah.
Dry the dishes.
Yeah, so or even some people have a wash rack, you know, and don't even dry the dishes. You just let them dry themselves in the air, you know. Okay, what else? Some other good ideas?
So in my house we have like this paper towel thing, but it's all like their own like rags, but they're reusable. So it's like the paper towel like a mesh.
Okay, so it's a reusable sort of paper towel, like a linen sort of roll that you reuse?
It's like they're squares that you like they velcro together,
Okay,
and it's just like little rags.
okay.
But they're like the size of paper towel.
Okay, so instead of using paper towels, you use reusable, washable, sort of like rags, that kind of thing?
We don't,
Yeah.
We can't.
Yeah.
We use so much paper in the house. So.
Yeah, that's very good. Yeah, paper and cleaning products, yeah, it's a big one. What else?
When we order like our groceries, we don't use paper bags. We reuse paper bags to like take out our compost bins. We just use the paper bags in our compost bins and then just.
Yes, okay. Okay, so paper bags are used for groceries, then you reuse them in compost bins, that kind of thing. Yeah, very good. And even the fabric reusable bags, right? I mean, everybody kind of has those, I think, now. Go grocery shopping, use those bags, and then throw them back in the vehicle. And okay, yeah, what else?
Rob the Costco for the paper box.
Rob Costco of their paper, of their
I
boxes.
literally- Yeah, I
Yeah.
literally intersect the one like the
Yeah.
when workers still.
So I've got this video here I want to show you, and it is the garbage barge video. It's on the website, so it's about 10 minutes long. So this is about a fellow that kind of came up with the idea of transporting fuel, and so this was the thing from back in the 80s when this kind of first started. So let's just watch this. You might find this interesting. Lights okay?
No one we know is particularly.
This way. I am not going to show this. All right, so if you want to watch that again here, a barge full of garbage helped to fuel a recycling movement about the Mobro, and here is the link on the website if you want to watch that again for any reason. Okay, let's keep moving on here. All right, so that's the end of section 7.1 in your textbook. This is 7.2. We're starting now. This focuses on liquid waste. So wastewater is any waste that occurs or can be changed into liquid form. Wastewater. Stormwater is wastewater that drains from lawns, driveways, roofs, roads, and other urban surfaces. So you've seen the grates and the just on the side of the street by the sidewalk there, right? This the storm drain. When it rains, you'll see that that's where the water goes, right? It drains to that spot. Also, you'll see if it rains really fast and a lot of debris gets taken with the water, these things can get plugged pretty easily, right? You know about that? So you're driving down the road and all of a sudden there's this big lake on the road, right? You gotta go slow through. Wow, there's some storm drain that's just been plugged with leaves or debris or whatever. So often also in the spring, when the snow that's been packed up against the side of the sidewalk on the edge of the road, when that starts to melt, it melts and freezes and melts and freezes in the springtime. And so you have ice forming here too. And so sometimes in the spring, you'll see people out there with their with their axes or their ice chippers, and they're trying to clear away this grate so that the water can drain. So, and a lot of times in the winter, because there's warmer air from the water movement underneath, a lot of times the snow just melts when it hits that and falls through. So it's usually open most of the winter, but if it ever gets covered, and ice can form there pretty quick. So good to, if you have a property and you have one of these storm drains on the sidewalk outside your house, like I do, good idea to keep those clear all winter long, and so you have no trouble in the spring. But anyways, that's a storm drain. So where land is available and densities are low, as on, oh, I missed something. Oh, the bottom half here, okay. Sewage is any material rinsed down a drain or flushed down a toilet. Sewage, okay? So even rinsed down a drain in your sink is technically part of the sewage. Liquid waste cannot be disposed of in a landfill. So that's just for solid waste in the landfills. Sewage is treated before it's released back into the environment. And if you're following along your textbook on page 277, contains a diagram and some more information about septic systems, which we will talk about right now. So, septic systems, here we go. So where land is available and population densities are low, as on remote acreages, often a septic system is used where wastewater is first drained into a septic tank near the house. So sewage first goes to this tank. The first stage sees solids settle to the bottom of the tank. So this is a picture similar to the one in your textbook, but this is the initial tank here. The solids all settle to the bottom, and the liquid remains on the surface, and that liquid is pumped out of the tank into the field now, or a bush or a low-lying area that can where the water can soak in. Sometimes it's underground, sometimes it is above ground if it's far enough away from the house or from other people. So the liquid evaporates, so if it's surface liquid at all, then it just evaporates into the air, and the rest of it sort of sinks into the ground. It evaporates, or it soaks into the ground and is purified using natural percolation, which is basically just the water kind of like falling through different layers of rocks and sand and dirt and stuff to strip away kind of the impurities and that kind of thing through different layers of soil, rock, and sand. Solid waste builds up in the tank. So now back to the tank here. Solid waste builds up over time, and then your septic tank becomes full, and then it must get pumped out every once in a while. So I'm not sure what the frequency is. It depends on how many people using the house and stuff. But I remember growing up on the farm, we had a septic tank. We weren't connected to any city water because we were way out in the farm, and so we had a septic tank, and every once in a while, Don's septic service would come in, and he would be pumping this. It would stink, man. I could imagine doing that for a living. Like, that's all the guy did every day was like pump people's
Same
poop.
with a lot of summer camps, I think, like the camp I go to has.
Yeah. Oh, for sure. Yeah, that's a common system. A way to, yeah, it happens all over the place. More places than you think. Now, if we're connected to city pipelines and stuff and water systems, I mean, it's different in the city, but most rural areas. Now, this is obviously, you know, it's far enough away from any groundwater that it won't directly infiltrate that, but there should be a lot of soil and sand and dirt and things in between, so that it's just regular water that drips back into the groundwater if it makes it that far. And of course, a lot of this liquid can get taken up by trees and whatever it's around. All right, it looks like I do have, oh, what is it? I think we've watched this video actually. Or no, this is the septic system video. Okay, hang on. Okay, so this video, again, what's it called here? How does a septic system work? And let's see, garbage bars. Here we go, it's this video. It's this video right here. This other video, actually, I think we watched this already, but we watched it a ways before. So this video here, how septic system works. That's what we're gonna watch here somewhere. Where'd it go? There it is. Let's keep going. We're almost done here. All right, municipal large-scale sewer treatment involves a number of steps, okay? So This is not talking about a single-family home out in an acreage here. We're talking about large-scale sewer treatment. Step 1 is primary treatment. This involves separating large solids from the sewage. And again, I think there's a video that we watched before, went over some of these. I feel like we've talked about this a bit before. Step 2 is secondary treatment, which involves biological breakdown of dissolved organic compounds. Chemical and UV light processes somewhat purify the sewage at this stage. So step 2 is mainly biological breakdown and a little bit of purification through chemicals and UV light. Here's a picture of with some wastewater treatment plants. Step 3 is tertiary treatment, in which the sewage is passed through a natural wetland or chemicals that are used to further remove nutrients, such as phosphates, nitrates from the sewage. So third stage. So solid removal, biological breakdown, UV light, chemical cleansing, and then some more chemicals or passing it through a natural percolating wetland to further remove nutrients and phosphates. So 3 steps there. When the sewage has been treated in this way, it's called effluent, and so that is partially treated, a little more clean, sort of refuse wastewater. So effluent, when it reaches a certain stage of purification, can be released back in the environment. Water from storm drains in many communities is not treated and is released directly back into the environment, which is where chemicals from runoff and can contaminate our water sources. So, yeah, in some places the storm drains just kind of go to a creek, which feeds back into a river, which goes back into a lake. It doesn't really pass through a plant. This is not a diagram that's in your textbook, but it's pretty close. In a lot of places, a catch basin or the storm drain, the water just basically goes to, like I said, a creek or a lake or whatever. And anything from your sink or your toilet or your wash machine goes through the sewer pipe into the wastewater treatment plant. So this is the way it is for the most part. All right. So that's the end of chapter 7 material. That's just the summary notes, the big high-level concepts. Chapter 7, you should be reading the textbook to fill in the blanks for your own understanding. For now, I want you to, for the rest of the class here, to work on, well, these are the questions from the chapter 7 review that I'd like you to work on. And that's on page 239 in your textbook.